Today in this video, I'll be discussing about rags. A lot of you might be hearing like, what is rags? Wondering what is rags? What is this? So let's get into and understand what is a rag. And first of all, before going to know about rags, let's go through why do we need rags? Like there are a couple of reasons. Like there are a lot of reasons why people wants to go ahead with the rag. So I have given few examples because as everyone started because of crazy generative AI boom, everyone started using LLMs, and these LLMs are pre-trained models, so they have a knowledge cutoff after they have data only set up to certain particular period of time. After that, they don't have data, so that is the reason. As these are, so I have one screenshot here to show that when the knowledge has been cut off. So if you see the OpenAI models, you can see ChatGPT 3.5. These are 3.5 turbo models. You can see the training data is still only till September 2021. So after that data after that, the model doesn't know. So how can we, if we ask some questions regarding that information to the LLM, they can't answer well. So in order to, that is one of the problem. And expanding the knowledge. So large language models are trained on very huge data set, but they might not cover all the data set that is available out there. There might be some information that they are not having it, and some like very confidential or like any information that you have with you, and that might be not, the model might obviously will not be trained on such data. So so expansion of knowledge is one of the application why they need rags, and also improve the accuracy and relevance. So sometimes, even though LLMs are very good in generalization and they can do all general tasks, still, if you give more context of what you want from them, so they do even better, because it is proved that because it's basically transformer is a best next word predictor. So it predicts the best next word about the all probability distributions in the world, in the words that are it's being trained on its tokenizer. So in order to get, like, if you have more context, these LLMs really performs well. In order to get deep into that, I will have a lot of other videos why LLM works better with more context. Altogether, it's a very huge topic, so I don't want to jump into that. So these are the couple of factors, and there are a lot of other factors which technically you might not need for the context of this video. The major thing I want to show is the knowledge. The LLMs doesn't have the knowledge on the context that you want to ask, so we give the context and ask LLM to answer that. And there are a couple of things I want to discuss. Why people uses cosine similarity. Like a lot of people might be wondering why in embedding space, especially they will use cosine similarity. Why not Euclidean distance in ML applications? As we see normal basic and ML applications, when we see the distance metrics, mostly we use Euclidean distance. But why in embedding space of RAGs, or normally when it comes to NLP, natural language processing, why people uses cosine similarity? And I will be discussing vector DBs and not language models precisely, but we language models to apply the RAGs. So let's jump into the vanilla RAGs. So in vanilla RAGs means like the first version of RAGs. So what is RAGs all about? Suppose you have a document. Suppose you have some. Assume that you have a financial document of NVIDIA 2024. You ask some questions to LLM. It can't answer because it, as you see, if you ask a GPT 3.5 Turbo, it can't answer that question. So when we want to know some information about financial documents of latest financial documents or latest research, it can't answer, but we have the articles with us. So what we can do is we can send that complete context to the LLM, and then LLM and ask the query that you want to ask, and LLM tries to answer us that question. So that is the thing we are trying to build here. So, but why people started using RAGs? Why can't you send, like, I have like 100, like I have a very huge document of 1,000 pages. I can just send it to you, because at the earlier stages of ChatGPT, it was having very less context window. It has like 4K token size. It's like very less. You can literally, if you send some 5-6 pages of document, nowadays, like there is recently I've seen on paper that they have infinite context windows. So in future, that might be not the problem, but as of when they started, when the vanilla RAGs was the like initial RAG stage, there was a lot of drawbacks of these LLMs, that they don't have large context window, and we need to come up with very good software engineering pipeline so that we can process these documents and send it to the LLMs. So what were they doing is like, they take a document. Obviously it is like, suppose I'll explain the Nvidia document that I was telling earlier. You have a document like 2024 financial document of Nvidia, and let's assume that you take that document and you want to ask a question. You can either, nowadays you can just send it, but earlier those days the context, like it's like LLMs were having less context window. So what they were trying to do is, they chunk the documents and they send. But based on how can I send, for which question, which chunk to send? That there comes a question, right? Which documents? Like, I have a lot of documents, and which documents, like if I chunk and send also, which partitions I need to send to LLM so that it can answer? I don't know, right? I can't search for every question and then get right. So it's not feasible. Or you can't do a keyword search. Earlier we used to do keyword search, all that. It's like we can't do that for every question. So what they come up with is, so what are the question you have? So what are the question you have? This is the user question. So what are you question you have? They convert into a vector. It's called embedding. So what is embedding? So it's like, basic example I can tell you is like vector representation of your question. Simple as that. So whatever the question, suppose the question is, what is GAAP profit of Nvidia in 2024 is your question. So what this embeddings does is, this is the question you want to ask to the document. What it does is, it creates a vector of this document. So this question, sorry, this query, this it creates a vector of this code. How does it create? We use an embedding model. Like how language models are there to generate the text, there are embedding model to whatever the question you give, it convert into a vector. This vector can be any dimensions like 512, 1024, or 4096. It depends upon the embeddings model you are choosing. And there are a lot of open source model, and as well as OpenAI provides text adder to, like it has 1036, I think 1024, 1326 dimension sizes, and I'm not pretty sure if the dimension sizes that they have along something like that. So let's get back to the retrieval part. So how does this rags work? So we have a question, we convert it into vector, we have the vector. Likewise, we have the document, we have our document. So in this document, what I will make the document into chunks, because we can't send the complete embeddings. And like how the language models has the restriction of chunk size, I mean the context size, the same way embeddings model also has, like it can take only to certain context window. They can't take unlimited amount of text. You need to give the only the context, like how much is the size that the embeddings model can take. That is also depends upon the types of model that are available out there. There are a lot of models out there, like it depends upon the embeddings model that you are choosing. So then what you do is, you take a text model, you take the document, you chunk it, like the chunk size may be like 100 words or 1000 words, based on you what you feel is comfortable for you. You can make one page as one portion, or whatever feels fit. Like now I'll draw a diagram and explain you. Suppose you have a document, it has 1000 words in it, and it has 1000 words in it. Now you made like a chunk size of 250, so it breaks like into four portions. This document 1, 2, 3, 4. So it's like it has 250, 250, 250. It has four portions of it. So we chunk it. Thus, this page is now converted into four paragraphs or four chunks, you can say. And now what I do is, now I use my embeddings model and I get four vectors of this page. Likewise, if you have 100 pages, you get 400 vectors. Like that, how much is the size of the documents you get? Like you can see, this is an example I'm saying. You can take Like you can take directly 1000 as your chunk size, you can take 2500 as your chunk size. This is like the hyperparameter you can play around with and see which based on the model and whatever you're choosing, which works best for your pipeline. That is like hyperparameter you can choose. And once you create a vector, now you have a query. At the earlier I have said you, we have our my query. What I'm trying to ask, like what is the GAAP profit of Nvidia in 2024? So I have a question. So this is also a vector. Yeah, same dimension 512. Suppose I have taken an embedding model of vector size 512, and these are also vectors of dimension 512. Now what I do is I see similarity between these two. So now I have a vector. Suppose I have made 400 vectors of 100 pages, 100 document pages. I made 400, like 250 chunk size, and I made 400 vectors. Now I want to send this context to my LLM. So how do I pick? Like I can't send, right. Like I said, I mean, we need to send only the context that is required as per my question. I don't want to send the complete document, right? So I want to select only few documents that are required for the LLM. So how do I do that? How do I do that? So I want to pick only a few documents that are like very similar to, I mean, contextually similar to. That's called semantic search. What is a semantic? Meaningful distance. Like as per my question, what are the possible context in the document that I need to send it to an LLM, open source, or ChatGPT to give me the required answer. So in order to do that, what we do is like now we have vectors, like 400 vectors we got. Now I want to pick either 10 or 20. Let's assume like I want to pick top 5 and give it to the LLM. So how do I do that? How do I pick top 5? How do I put is like there comes the concept called cosine similarity. So how does this cosine similarity works? Let's go and let's get an explanation about that. So suppose you have a word called good in the embedding space. Like there is a embedding space. Like suppose there is a word in your context. Suppose there is a word called good, and there is another word called very good. They are very similar. Like assume this is a axis. This is an x-axis. This is y-axis. Like you have a two-dimensional data, two-dimensional representation of embeddings. Like now assume that you have vector embeddings of just dimension is like two-dimensional. For your understanding, I'm saying that. So you have good and very good. Now you have two words. This is one vector. This is another embedding. This is one embedding. This is another embedding. Now I want to find the distance between them. You can use Euclidean distance, root of x1 minus x2 whole square minus x1 minus x2 whole square plus y2 minus y1 whole square. If you get the Euclidean distance, you get the Euclidean distance. But why people are not using Euclidean distance, but why they are using cosine similarity here? This is one good example. Suppose you have good and very good. Suppose the distance between this is like maybe like 225. Even though good and very good are like the meaning is same, right? Why do the distance is too high? And suppose there is another word called bad, and it is somewhere here, and the distance is like 24. Not like very far, like or 30. Make it like a little far, like it's 30. The distance is like 30. Okay. So when it is picking the documents, like I said, right, when I asked my question, I told I want to pick, right, pick the documents, stop picking documents which are like very similar. I want to pick the vectors that are similar to the question I'm asking. So in order to do that, when good and very good, the distance is less. But let's say we say cos. So what is cos? In cos theta, if we get dot product of what I mean cosine similarity, it's like dot product of both vectors divided by their magnitudes. If there is two vectors, this is A, this is good, A is good, and B is very good, assume that. And what is the angle between these two? Theta is 0. Because there is like on the same line, so the theta is 0. So then cos 0, you know what is cos 0? It's 1. So 1. So what does that mean? In cosine similarity, -1 tends to like they're very far apart in the embedding space, and the range of theta is from -1 to 1. So minus one saying that the model is like the both the embeddings are far apart from each other, but one being very near to each other. There are close similarity between them. So when I find the similarity, when I find the theta between the cosine similarity between these two words, it's one. So then what happens these two is like it gives like I get cosine similarity of one. But if when it comes to this, maybe the angle is some 60 degrees and cos 60 is 1 by 2, it's like zero point 0.5. So the bad goes very far, like the distance between good and bad is because of cosine similarity, you can clearly segregate good bad and in embedding space. Now I think you get my idea what I'm trying to say. So that is the reason why people go ahead with cosine similarity in the embedding space, but not the, even though the words are very similar, but the distance might be heavy. So I think I feel I have given very good idea on why people use cosine similarity but not the Euclidean distance. So that is something I want to tell. And now I have explained. I have taken a document that is done, and we have created a vectors like vectors of dimension 512 or 1024. My question is also vectorized, and my the documents are also vectorized. The 400 vectors we have. Now we want to pick. Now what I do is I just find cosine similarity between my question and all the vectors out there, and I will pick top four. Like there are 400 documents, 400 vectors, and I have my vector, my query vector. I will find the cosine similarity between all the vectors. Oh, and I'll pick top four or top 10. What is it's a hyperparameter? It depends upon the model context. Again, if the model is you have very good context window, like you have like 128K context window, you can literally send 100 documents. But the context is like you will have a lot of context that is unnecessary. You want to make sure. However, here the goal is to keep the context very close to the question that you are asking. So let's say my example here I will be completely discussing with the four I want to give like four vectors context to it. Then what I do is now I picked like based on my question similarity I got my four documents like it out of like maybe like 100th document or like a 200th document or like 174th document or like 276th document like I don't know like it can be any document like which is having highest similarity. I get that. So how do we get there? Like you can use like there are a lot of open source and there are like a Pinecone, like there are a couple of vector databases like Pinecone, Milvus, FSS, ChromaDB. But my personally, my favorite is FSS. You can say I'm a meta fan, but yeah, I like FSS because I like pretty much customization, so I can customize it however I want, and I can do a lot of crazy stuff with it. So I like playing around with FSS, but you are up to choose anything because this question similarity, right? To find between one vector to all the other vectors, it's like it's very computationally expensive. So what I would say, use these. They make this search very fast. So you just have a question query vector, you supply to them, and you can basically find these 400 vectors and index name FISS vector DB. So this is an FISS vector DB. What you have done is you have kept your 400 the documents whatever you have find 400 vectors, you just put them in this DB. And what you do, how you query a database, you write, suppose you have a database, you query them with an SQL query. But now how do you query is in these vector database is the query is just the question that you are trying to ask. Then we have the vector of it, and we have the we have the vectors in the DB, and FSS will bring top 5 documents in a very optimized way. So I can give that. That is a hyperparameter K. There is a hyperparameter there. You can give it 4, 10, whatever the hyperparameter is. Like you can play around and feel comfortable with what you feel like working well for you. So there is a question. There is a vector DB. It goes and picks top four. And now why we have done all this? Because we pick the documents that are required for us. Now what we do, we take all these documents, send it to an LLM, and get the response out of it. So let's see the pipeline. So we have a documents. Now we have made the chunks like I have explained. Then what do I find? For each chunk, I have made one vector. That's it. That I have stored in vector DB. I have explained so far. I have user query and I have made vector embeddings out of it. Then I did retrieval. What is a retrieval? I've used any vector databases, or you can write your own code to find the cosine similarity between and pick top 10 documents. That's completely up to you. But I would say it's like don't reinvent the wheel. Use just the tool that is available. FISS, there are a lot. I'm not just saying you can use FISS. There are everything, a lot of tools available out there, which feel free to use whatever is comfortable with you. So that picks the top k chunks, like it picks the top four documents. Then what I do is I will send LLM. So LLM, what I do is I write a prompt that hey ChatGPT. Let's suppose I'm using ChatGPT 3.5 Turbo API. I write a prompt. So I'll tell LLM that hey, here is my context of that I wanted, and I give the context here, and I have user question. That is the question that the user is asking, and based on the information above, try to answer my questions as good as possible. Some prompt, you can see a lot of prompting thing, and you can play around with a lot of prompts and try to get the best prompt out of it. And I think it is pretty straightforward prompt. I don't think so. You need to work a lot on it. You can just tell, here is the context, here is the question. Based on that, try to answer that. And you can come up with the best prompts to make sure that LLMs give that they don't go and their knowledge. They try to use the knowledge that it's available there. You can put the prompt in a way that they can do that. So that's how the RAGs pipeline works. I think you guys had a pretty good idea on what a RAGs is. So yeah, this is pretty much about the RAGs, and I want to discuss. There are a lot more advanced implementations of RAGs. So in my next video, I will be discussing how that advanced RAGs are available. What are the different strategies to make this pipeline even better? So thanks for watching. Do like, share, and subscribe my video. Subscribe to my channel.